Hello pre-calculus students, and welcome to the continuing series of videos on approximation methods and an area under a curve. So in this video we are going to talk about three different methods: LRAM, RRAM, and the trapezoidal method. So LRAM stands for left rectangle approximation method. Left rectangle approximation method. This is also sometimes referred to as the left Riemann sum, named after Bernard Riemann, who developed the idea. It's not exactly the same thing, but it's often used interchangeably. Okay. So let's just do an example so that it's easier to illustrate that way. So let's say you have this graph here, 8 minus x squared, so that's going to look like this. This is going to be square root of 8, and this is negative square root of 8, where the intersection points are with the x-axis. Okay. And we want to approximate this from negative 2 to 1, okay, using 4 subintervals. So basically we're going to cut this section here into 4 different subintervals, and since this has a length of 3, that means each subinterval is 3 over 4 because we want 4 of them. So this is a length of 3, so each one of them is going to be 3/4 long. So that means the points that we're concerned with is going to be here. So negative 2, that's negative 1.25, then negative 0.5, and then 0.25. And I realize I am not drawing this to scale at all, but hopefully you are still able to follow the overall concepts. Okay. And since it says left rectangle, so we are basically going to use between this length here and this length here, we're going to use this one as the height of our rectangle. Between this height or this height, we're going to use the leftmost one. Between this one or this one, we're going to pick this, the left side. And then between this here or here, we're going to use the left side again. Okay, so, and if you notice here, let's see, the first rectangle is going to have a base of 3/4. That's just this length here. And a height, well, this height here is f of negative 2. In other words, put negative 2 into this function, and that tells us how high this is. So f of negative 2. This next one is going to have a base of 3/4 and a height of f of negative 1.25. One after that is also 3/4, and that's going to have a height of f of negative half. And then the last one is going to have a height of f of 0.25. Okay. So it's a little bit tedious, but we can factor out 3/4, and then we can just add up what the rest of these numbers are. Okay. And I'm going to show you a quick little trick on your calculator that will allow you to do this faster. So in your TI-83, TI-84 calculator, I would go into the graphing function and graphing feature, and I would type in this function 8x or 8 minus x squared and exit out of there. And your calculator has this nifty feature: hit the vars button, go over to y vars into function, and I'm going to pick y1, and then I'm going to substitute in here negative 2. So this is basically doing f of negative 2 plus, same thing again, negative 1.25 plus f of negative 0.5 plus f of 0.25. Okay, so that gives me this sum, and then just multiply it by 3/4. So that is 19.59375. Okay. And you can see here, this is not an exact answer at all. This is just an estimate of this area. You can see that in certain parts here we are underestimating it, and over here we are overestimating it. So now I'm going to do the exact same problem, but I'm going to use the RRAM method instead. So RRAM stands for Right Rectangle Approximation Method. Okay. And we can also, it's sometimes called the right Riemann sum. Again, that's not the exact same thing, but it's almost the exact same thing at this stage, and you'll hear it used almost interchangeably. So with the right approximation method, all we have to do is recalculate this, but instead of choosing the leftmost points, we're going to use instead of using the left points, we're going to use the right points for every rectangle. Okay, so I got the same picture. I just erase all the other stuff. So between these two heights, we're going to pick this one. Between these two heights, we're going to pick the right height. Between these two, we're going to pick this one. And between these two, we're going to pick the right height again. Okay. And you can see that it's the same thing that we had before, except now what we're going to have is 3/4. All of the stuff in between it, we're going to keep it. So it's going to be f of, instead of -2, we don't use that anymore, so it's going to be f of negative 1.25 plus f of negative 0.5 plus f of 0.25 plus f of 1. So the distinction here, or one of the big differences, is that we have 1 here, whereas before we had -2. Okay, so we sort of, and then everything else is the same. F of negative 1.25, these two values and these two values are all the same. So nice thing about this is in my calculator I can basically do almost the exact same thing, bring back what I had before and just replace this with f of 1. Whoops. Okay, so all the other points in between I've kept the same, and I've gotten rid of -2 and I put in f of 1, because that's essentially what RRAM is. Do that and then multiply by 0.75. So that gives me an answer of 21.84375. And there you have it. I'm going to end this video here and start another one that talks about the trapezoidal method, and it's a similar concept. Instead of making rectangles on the right and on the left, we're just going to make a bunch of trapezoids. Thank you for watching, and have a wonderful day.